load into your minds kind of how your peer matching program is going so far. All right. What's the algorithm you're using? Like, what issues have you had? All right. Lots of you are using very advanced things and stuff, and we want to make sure that that we take care of some of the lower level things. And again, some of these things are going to be on your upcoming tests. You're going to be doing slides over them and stuff, but it's really useful to see these things in the context of real stuff. So let's look at some really basic things, and we've talked about some before. So here's some peer matching program useful skills and techniques. All right, this first cell. If I want to say that two names are equal, all right, I can declare a couple of variables and assign some strings. All right, and now I'm just going to have a quick conditional tree, and I'm going to check to see if player 1 is equal to player 2. So now equals is the equality operator. All right, 1 equals is, what do we call 1 equals sign? Assignment operator. It assigns values. So if you have equals, that's, are these things exactly alike? Okay, and then the opposite of that, and again, you'll have copies of this, and you can see this opposite is a sign called exclamation point equals, which means not equal to. And we'll use both today. So if you want to see something is not equal or equal, you've got those two operators. So if I run this, we would expect this: if player 1 equals player 2, then print they are equal. If it's anything else, print they are not equal. So when we run this, it's going to say they are equal. All right. If I take off a Y, all right, it's going to say they are not equal. All right. What about, and then you also have some kind of cool things like this. Would these be equal? Yes. I'm sorry? Say one more time. The Google Meet screen is what, not showing?
It's on your Spotify.
Oh, it's on my Spotify. Nice. Lovely. Hacking music. Can you see it now? Okay. So here we were playing around with these two things, okay? So, and the video had this one recording. All right, so now, are these two strings the same? No, they're not. Okay, what you're going to learn here pretty soon is we can have some string methods, and you're going to be learning these. So let's say that I wanted, if the name Andy came up, no matter what the case was, I just wanted to see if I had the name Andy. I can use something known as a string method to check it. I can go dot lower, okay, and what will happen is dot lower will make whatever player 2 is all lowercase. So now when I run this, it's going to say they're equal. So like if I don't care about the case, how they type it in, all right, I can do dot lower, I could do dot upper. The best practice would be to make both of these dot lower. Okay, that way I'm comparing apples to apples. But that depends on what your use case is. Do you want it? Do they have to be the exact same case, or are you just looking for the actual value? Okay, that's a little bonus. I'm going to take that back to the way it was before, but I could even do. Whoops, sorry. I could do that. Is that going to print back that they're equal or not? It will say that they're equal because it's going to make them both lowercase before it compares them. Excellent. All right, cool. So we'll come back to that. So I'm going to take that off real quick. All right, questions about that? All right, sweet. So just basic comparisons. All right. Now, here is a bigger if, elif, else tree. All right, couple of things here, and we're going fast through these things, folks, so I know that there may be a lot here. What we're wanting to do here is we're trying to work on the spelling of the word necessary. This was one of the banes of my existence for some reason when I was in middle school. I could not spell this word. I never could remember if it was one C and two S's or two C's and two S's or two C's and two S's. Like I just couldn't. it was just one of those words I had a problem with. So let's say I've got a little bit of a checker here. I just want to see if it's spelled correctly. So we take a correct spelling for whatever word we're practicing with. We get user input. And then we're going to check, are they the same? And if it is, print correct spelling. All right, and then I've got some other cases. Oh, this is correct, but it's in all caps. This is not correct. You put in an extra C. This one is not correct. There's supposed to be 2 S's in necessary. And notice the escape character, by the way, to get that extra, that probably would have worked without it, but we'll see. All right, so let's go through each of these. And this is where you need to pay particular attention to when the conditional tree stops. Okay? How many of these conditions are going to execute? There's 1, 2, 3, 4, 5 conditions. When we run that, how many will execute? 1, and only 1. The first one that it hits that's true, it's going to execute. If it hits 1, 2, 3, and 4, none of those are true. Anything else, all right, it's going to run else, because everything else will be false. All right, so it's going to run only one of these if, elif, or else statements. And as soon as it finds one that's true, it's going to stop right there. So let's run it, and I'm going to put in necessary and spell it correctly, hopefully. And it says correct spelling. So that means if user input equals correct spelling, print correct spelling. All right, it stopped right there. None of the rest of this code ran because it found a true case. Questions about that? All right, let's change it to, I'm going to put 2 C's and 2 S's in. All right, now this was false. All right, this was false. This was true. So this is going to run right here. All right, and the rest of this will not run. And then let's do one more with just a gibberish word. Okay, none of these first 4 are going to be true, so it's going to run, sorry, hang on. It's going to run the, I messed that up, hang on. It's going to run the else statement. Not true, not true, not true, or sorry, false, 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 false. So it ran that one. Okay, so basics of, you're gonna work through slides in much more detail, but what I want to do today is jumpstart you, make sure you've got a few skills and techniques to use on your peer matching program, okay? All right, cool. So that's those. Questions about this conditional tree? All right, moving along. Now, let's talk about, we're going to do necessary again, but this time we're going to run a loop. All right, we're going to run a loop that's going to go, it's going to check to see if the user input is not equal to the correct spelling. If it's not equal to the correct spelling, all right, if I say the letter A is not equal to necessary, it's true that that's not equal. And so it's going to say you spelled this incorrectly, and it's going to ask for user input again. Okay, and it's going to keep asking until you get it right. So let's run it because it's got a while loop there, and you can see the syntax and stuff for the while loop. So if I just say NE, you spelled this incorrectly, try again. You spelled it incorrectly, try again. H. It's just going to keep on going. Notice that there's no built-in number of attempts or anything. We're going to do that in a second. Now let's put in the correct spelling. Now, as soon as it sees, oh, this is going to be false because on this last one, necessary is equal to correct spelling. So that's false. So it doesn't run any of this, and it jumps to the next line of code. All right, cool. Questions about that? All right, excellent. Now, let's say that you want to check to see if some passwords match. It's the same deal as we had before. All right, we're going to have input. We're going to have stored username. It's the same structure as this one before. I just wanted to show it to you with passwords. So there's nothing really new here. Same stuff. Now let's do a guessing game. All right, you got a secret number, you got a guess count, because we want to track how many guesses it takes to get the number. And we're not giving any hints here. Okay, a couple of things to note. We set a secret number at 7. We're going to initialize the number of counts at 1. Okay, because this will be the first guess. And once they guess, we're going to see, hey, while they're not equal to each other, let's add another guess and then have them put another guess in again. All right, so let's run this code. And we're getting close to being done, folks. So if I put in 5, 5's not equal to 7, so it's going to ask me again. I'm going to put in 9 plus. That was not correct. 456, that's not correct. 44, that's not correct. And now I'm going to put in 7. Was 7 not correct? Secret number 7. Oh, we got a bug. Let me try again. All right, let's look and see what's causing a problem. I put in 7, but it wasn't working. So, what did I do? Guess count. Look and see if you see the bug, folks, because it's running, but we're getting incorrect stuff. So secret number is 7. While secret number is not equal to user guess. Okay, what you got? Gotcha, perfect. So you see up here where that's great. Input always comes in as a string. Up here, we cast it as an int so that we can compare an int to an int. Down here, when we collect it again, we did not do that. So whatever we collect, really good job debugging that so quickly. Both of you. I saw 2 hands go up, I think. So now, if we put in 7, it should work. Well, I've got to restart let me stop this and restart it. I'm going to put in a few incorrect. And now we'll put in 7. And then 4 guesses. So 1 guess, 2 guess, 3 guess, 4 guesses, and we guess it in 4 guesses. Okay? What could we do to improve that game? You could tell somebody to guess a number between 1 and 100, and if they don't get it, you could put some if statements in and say, your number is too high, your number is too low, and stuff. So you could expand that game into allowing them to narrow it down. Okay, I didn't do that here just for sake of time, but something you could play around with. All right, now other skills, and this is where the skills that really apply. This skill will really apply to what you've got going on. Lists and list memberships. Okay, because lots of you, for the peer matching program, you're trying to see if certain adjectives show up in lists and if certain names show up in lists. So you declare a list the same way to start with as any variable. So I'm just going to put users and the assignment operator, and to declare a list, and I'm declaring and initializing one right here, I use these square brackets. And for each item in the list, I separate it by a comma. I can have a list of strings like this. I can have a list of numbers like ints or floats. I can have a list of strings, ints, and floats all together. Python is very unique in that aspect. Most languages don't do that. They make the data type all be the same. All right, so if I just want to see if a name is in a list, okay, and let's call these happy users. All right, these are our happy users, and we want to know, we're trying to match some people up. I'm just going to change that. Super simple syntax. All you're going to have to do is use the keyword in, and I can say, hey, I'll write this expression, Corey in happy users. And so what Python's going to do is it's going to take Corey and it's going to look through each item in there and see if Corey's in there. And if they are, it's going to say true. And if they're not, it's going to say false. So, all right? True and false. I can also take input. We'll take that suggestion. Enter a name. Okay, so now we could put in true. She's in there. Now, here are some other things you can do that. You can say if, we could say, hang on, sorry. I'm just going to do check name equals, I'm going to put in an empty string, and I'm going to say if check name in happy users, print they are in the list, print they are not in the list. But let's say if check name in happy users, we want to award them player score or user score equals, we're going to start it off, sorry, at 0. Almost done, folks. Hang in here with me. User score equals 0. And we might say, if they're in the list, user score plus equals 1. We're going to add a point. Yes? Have what? What line? Yeah, thank you. Got it. So, thank you. If check name in happy users, user score equals plus equals 1. And actually what we'll do here is we'll put, all right, we'll use it as input. So if they're in there, we're going to give that user, we're going to give that user, we're going to give check name plus 1, or we might make it, I don't know, whatever. We'll leave it right there. So check name, we'll give them plus 1. If they're not in there, then we may want to say we can give them 0 or just do nothing, and we could pass. All right, and then we could print out all right, we could print this out or not. Print check name has the score. I need one more parentheses. Yep. We're going to look for who's in there. Corey. Enter a name. Sorry. And now Corey has a score of 1. So hopefully you can see from that that you could very easily check if you have a list of happy adjectives. If you have a list of maybe you have a list of happy adjectives, and those adjectives add to a positive 1. But maybe you have like super happy adjectives, and if they have one of those adjectives, they get 2 more. All right, and let's say that the whole peer matching program is you're trying to match positive people to positive people, and negative people to negative people, so they can suffer together. All right, that way the happy people stay together, the others just like go kill each other, like whatever. Alright, so hopefully you're starting to see some techniques that if you've got like a list of super happy, if they're in that list, or if they have an adjective that's in that list, then you can give them 2 points or 5 points. If they're just in the happy one, you can give them 1. If they're in a list of neutral adjectives, they don't get any points. Then you have negative adjectives, you give them a certain amount. You have even more negative adjectives, you can give them even more. Okay, so lots and lots of ways to do this. Being able to do that with lists could potentially help you because you can keep track of your users, and then you can start developing. Developing lists of happy users, and then you can start saying, okay, these 2 match. All right, another little trick, real quick, and then I'm going to let you start playing with things. print all members in a list. This is just a way if you want to see everybody's in a list, just a quick for loop. We'll print all the members in a list like that. You can just print a list, but it's not very pretty. You can just say print users, and it'll print it just like that. Okay. So there's some skills that could help you. But now I want to hear from you. I want to give you like 2 minutes to talk to the people in your group. And I want you to talk about, is there anything that Mr. Fox can show us right now that would help us with our project? Okay? So think about 2 or 3 minutes and think, what other skills might we be missing that I can accelerate for you? Okay? Go ahead and do that real quick. What other skills could I accelerate? Maybe 3 minutes, and then we'll come back and talk about it. If you volunteer, sometimes you get this stuff coded for you, which is nice. Nothing? You got it all down? Yes, sir. Hang on 1 second. Make sure you're listening when other people talk so you don't ask the same thing. Then you'll have a chance to talk to each other and figure out what you need. Okay, go ahead.
So if we were to have get put in a new person's name, how would we assign a score to that essentially?
All right. So if you're putting in a new person's name, how would you assign a score to that? So that's really an algorithmic problem. Just based on the name, can you assign a score? No, you can't. You can't assign a score just based on a name. Okay, what data are we going to need? What data are we going to need to be able to do that? Or just give me an example. A sample algorithm. Yes. Okay, so let's say we need to know their traits. Traits, and let's say and hobbies. Okay, let's go with hobbies for just a second. All right. What if we say Paul has some hobbies here? We want to say horseback riding, maybe. That almost came out as horror riding, which that would have been bad. Horseback riding, that would have been really bad. And then cooking. And what else? One more trait. All right, cricket. All right. Now, instead of necessarily assigning a score, let's see if we can assign matches. Okay? I'll show you a little technique here. So let's see if we can assign matches. So let's take another user and let's say Rithan. And Rithan, all right. Everybody okay? All right, hang in over there. If you need the Heimlich, let us know. Football, dancing, and I don't know, something really nice like ballet. There we go. All right, ballet. I was going to put nose picking, but ballet is much more couth. All right, so if I just wanted to see if they had any matches at all, okay, don't worry about the code right now, but if I wanted to see if they had any matches at all, I've got two lists. How would I check if Rithan, let's take Paul's first hobby, horseback riding. How do I check if Rithan has horseback riding in his as well? yeah, I could loop through and check each one. All right. But I've got to check the first one, right? So I'm going to try to keep you all out of what's called nested loops right now. But I'll show it to you in just a second. But I could say, all right, I want to look at Paul's list. So first of all, go back. We'll just jump straight into this. So we got for trait in Paul. All right. That's a nice loop, but that's not what I want right yet. So we're going to say for trait. By the way, you can name this whatever you want. So the list name is Paul, okay? So these words, I could say for I, the letter I in Paul, I could say for trait, but it's just a local variable. It's just going to be in existence while we go through this. So if I use this loop called a for loop, I can say for trait in Paul. In other words, I'm going to bring in each trait one at a time. So just so you can see that again, I'm just going to print trait. And I'm not going to do Rithens right yet, okay? So just so you can see that it processes all of the traits. It did. It brought horseback riding in, and then it looped again, and it brought cooking in, and it looped again, and it brought cricket in. Okay? So one easy thing to do is to say, I can put an if statement in here. I can say, if trait in Rithens, all right, print trait. So let's see if there are any traits. So I bring in horseback riding. If horseback riding is in Rithens, it's going to print out that trait. Okay, if it's not in there, it won't print. And it's going to see if cooking is in anywhere in here. And then it's going to see if cricket's anywhere in there. So let's see if there are any matches. No matches. All right, so let's put in, and these can be uneven. All right, let's put in now. They share cooking. Okay? They share cooking. So you don't necessarily have to do this on a point thing, but what you could do is we could also do, so questions about that so far? All right, so if you want to see if something, like you've got two sets of traits and you want to see if they can go together, now hopefully you should be able to see, hey, we could add in a point system to this, like if a trait's in Rithens, then we're going to add a point as a match. If there's not, then we just pass. Okay, so I could totally do, that's one way to do it right there, or I could do this. I could say if trait in Rithens, we could have matches equals 0, and then as they get matches, I could just add it. And I could say matches plus equals 1. All right, and then I could print the matches like they suggest. And so now, when I run this, I've got one trait that matches. Now, what if I do, let's add in, I don't know, running. All right, cooking, running, both match. The first two lines are from this, and then we have a match of 2. All right, so now we can do things like if matches are greater than or equal to 2, print these might make good partners. Okay? And now you can start imposing some conditions on things. Like you can just count things, you could add points to it, like whatever you want to do. Okay? So there's a possible Excel